multiplication law for independent events. So that's kind of, I don't know, 3/4 of the way down on the first page on the left column, if you're looking.
Okay.
And it is this, this is exactly what it is. Independent events. You just multiply the two numbers together and you get 0.04. You allowed to use a calculator on this?
Yes.
Great. Okay. There is some symbol there's this symbol right here. This one's a little bit different. I mean, we don't have to get into that unless you want me to. Multiple choice can be very tricky in some ways.
Yeah, I would like to explain the symbols
Sure.
different, please.
So this symbol means it means intersection, and usually it goes with the word and. And in terms of a Venn diagram, it's the overlap. So
Okay.
they have to both be true. The one that's related to it is the union operator, and it means or, but it doesn't mean or the way like we think of or. It's a logical or, which means it's one or the other or both.
Okay.
And it's kind of unclear, but it's everything in this overlap. So the person who understands this, if they're asked a question like, do you like pizza? Do you want pizza or ice cream? They answer with the word yes, because they mean both. They don't mean to choose one, which I think is the problem here. We think of or as one or the other, but in statistics and this logic, it could be one or the other or both.
Okay. That makes sense.
That's it's just a distinction that we make in these courses. So, by the way, which, if you don't mind sharing, which class is this, or which department?
Business stats?
Business stats. Okay, like the Econ 212 or 221.
Yes.
Okay. So I'm helping someone else, and they're not. I don't think they've got anything like this. At least they haven't showed this to me yet. Must be a different teacher. Okay. Moving on to question 3. Is that okay?
Yes.
Which difficulty of range as a measure of variability is overcome by interquartile range? So I think first thing is, like, do you have an understanding of what interquartile range is, or how to calculate it, or anything like that?
Like kind of, but I kind of get confused a little bit. I kind of know like what range is already, but I do get a little bit confused.
So the formula, which may not mean much, is Q3 minus Q1. Okay, so when you have a data set, the median is right in the middle. And then Q1 is the middle of the first half, and Q3 is the middle of the second half. So we could use a numerical example if you wanted to do this, but it's this width between basically the 75th percentile and the 25th percentile.
Okay.
Maybe it'll ask us for, well, it does in the next one. Maybe we should do the next one first, but nevertheless here, this is a tough question because you have to know what interquartile range is, and you have to know what affects interquartile range. Okay. Let me give you the answer and then go backwards. Is that all right?
Yeah.
It's when there are extreme values. Okay. Like, let's just say we added another score up here to the right. The interquartile range might adjust, but it would only just adjust a tiny bit. Whereas the range, which is the max to the min, it's going to stretch based on that extra point there at the end. But the interquartile range, it might move a little bit. I guess maybe that wasn't shown very well. It might move a little bit, but its width is relatively the same even after moving. But extreme values, they push it out left or right. If that doesn't make sense, I'll give another example here, but
no, that actually did make sense.
Okay. Okay. You're my last lesson today, so sometimes I don't know if I'm still coherent or not.
Okay.
But Let's move on to question 4, where we actually have to calculate the interquartile range. If you're allowed to use like a TI 83 or 84.
Yeah, that's the calculator I'm bringing in, but we can
Okay.
only use it for factoring and then the 10 digits it has on it. He doesn't want us using anything else.
Okay, that's what about to give you is, here's the shortcut to do this. All right, so there's always a recipe to do a lot of these math stuff, and the recipe here is to put them in ascending order or increasing order. Okay. So to do that, I like to cross them out as I do it. 17. Okay, there's another 17. Okay, 18, 18, and then 20. All right. And like I mentioned in the previous problem, you then find the median. The median is the middle number. There's the median. Okay. Now the interquartile range, you have to split up. You basically look at the left half and the right half. Okay. And what's a little odd here is because there's two numbers, you end up having to take an average of them to find Q3, and then an average of them to find Q2. So the 17 and 17 average is 17. The 18 and 20 average is 19. So your IQR formula is Q3 minus Q1. In this case, it's 19 minus 17, which is 2.
Okay, that made sense.
Great. And it does, go ahead. Sorry, go ahead.
Say there's like 3 numbers on quartile 1 and quartile 3. Would I just add them up and divide it by that number?
That's a good question. Like, let's say it was 17, 18, 19, 20, and then we'll get to these over here. We'll go 22, 23, 24. You would actually just use the middle number.
Okay. And then, okay, that makes sense.
So the answer is it depends on the data set. There's like 2 rules. Now, I mean, if I were a student and I had a calculator, I might put the data in list 1 and do the one variable stats, if that was an option, even if they, I might try to bend the rules there a little bit, but that's at your discretion, of course.
Okay.
So, okay, here we go. Number 5 here.
Yeah.
All right. The probability of at least one head in 2 flips of a coin is, so it's this at least is a key part of it. All right. When it's small, like when there's only 2 flips, I would recommend drawing the sample space or writing out the sample space. And it's not too bad. We've all flipped a coin. It could be like heads, tails, tails, heads, and tails, tails. However you want to do it, like if you're the type to start with tails, that's fine. Just have some way that you always do this so that you get them all.
Okay.
Okay. All right. Now we want at least one head. So we got to look here at this list and be like, all right, well, that's got one head. It's got 2 actually. That's got 1, and that's got 1. So the probability is of whatever the event is. In this case, it's at least one head. It's like what we want over the total.
Okay.
And there's 4 total. There's 4 possible, but there, how many of them how many of them are good?
3.
3. There's your answer.
Okay.
Now this kind of is a binomial, like it is, but it isn't. It's so simplistic that you wouldn't use a binomial distribution, which I can kind of see that's where you guys are going in this part of the course. Maybe not. Maybe that's upcoming.
It's probably, we haven't done that yet, so it's probably
Okay.
not after this exam.
All right. Yeah. Good. That's good to hear, because I don't want to give you things that are unclear. All right, so let's go to number 6. All right, assume your favorite soccer team has 3 games left to finish the season. The outcome of each game can be win, lose, or tie. How many possible outcomes are there? So there's a couple of ways to do this. You could, just like we did in the previous problem, you could say, all right, well, it could be win, 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 lose, win, win, tie, and you'll realize that this is going to take way too long. Okay, so then I like using the buckets. I think of these as buckets, and they represent game 1 in this case, game 2, and game 3. And what goes in the bucket is the possibilities. What are the possibilities? Win, lose, or tie. And there's 3. For game 1, you could win, lose, or tie. I don't think there's ties in volleyball, unless the rules have changed.
No, there's not.
Yeah, win or loser, but we know in some sports there's ties, I guess. So, but game 2, is that the same? Like, or is there something from game 1 that impacts it? And the answer is no. They're independent. Like you play a game and you win or lose or tie, and then you go to your next game, you win or lose or tie. Go to your next game, you win, you lose, you tie, and you always multiply these buckets together. So don't make the list unless it's a small list. Build these buckets if you can. This would have been similar. Sometimes they have like a if you've got 5 shirts and 3 pants and 2 belts, how many combinations are there? Or, ice cream, if you're like, there's 10 flavors and 2 different cones, and these are the kinds of problems that you might see. Okay, number next, whatever this is, 7. The reason I'm not putting the numbers in is sometimes people get weird about having the numbers in there. So hopefully it's clear when you look at this later. They're asking for the mean, and they're giving you standard deviation and coefficient of variation. So you likely have this formula on your formula sheet. It does not look like you do. I don't see it there. So let me just grab it. I just want to double check that it is what I think it is. It is sigma over mu. Okay, so mu is what we're trying to find. Sigma is what's given, and the coefficient of variation is 64%. So that's got to be converted to a decimal. So you have 0.64 equals 8 over mu. Because it's multiple choice, I might consider just testing the answers, but you will find that mu is 12.5.
Okay.
So this formula didn't look like it was on the sheet. You might want to ask, well, I guess your test is tomorrow. I can't find it, but it's pretty, this sheet is very, I don't know what the right word is. It's very dense, so is that good enough?
Yeah, and I'll just memorize that formula for a question like this because it's a simple one.
Yes, yes. All right, in a data set, the number of elements will always be the same as the number of, so this is interesting. So I'm drawn to, okay, so I'll tell you what it's not. It's not those. Observations and data points, the number of elements. Do you have notes? I mean, does this look familiar to something you might have seen in
Maybe.
class? And I'm gonna use the wonderful internet here, but it's just oddly written. It's written in a way where the teacher, it's using kind of their language.
Yeah, he does that with a lot of his questions.
Okay, so I'm seeing that this is a good answer to go with. It's just really odd. Number of elements, distributing the elements. Like, what does that even mean? I don't know. Maybe check the notes if you got, you could compare to.
Okay.
That this is, I mean, I feel pretty comfortable telling you this, but I don't have much more to say. The idea here, though, is that when your data set's a bunch of numbers, like I don't know, points you score in a game or something, 10, 8, 6, 12. And these are each observations is the idea. Like if you were standing off to the side watching the game and you saw these point totals, you would record them. But it feels like it's also this one, but this is very specific to your class.
Okay.
All right. Oh boy, another one of these sort of gray zone questions. In a post office, the mailboxes are numbered from 1 to 4,500. Okay. So the issue here, like jerseys are a better example. If you wear a jersey when you're playing a sport, and that number on the back of the jersey is only used as an identifier. It has no numerical significance. Would you agree with that?
Yes.
Okay, but if you're putting mailboxes, like the number matters to identify the box, but does it go beyond that? Like, is there any reason that one is ahead of another? And that's the question we're trying to answer here. So with the jerseys, they're categorical. Okay, but the question is well, are mailboxes different than jerseys? And I, starting to think of like, well, addresses being, kind of like, they tell you how far away you are from the center of town in some regard, but I think of these as just categories. So I guess I would go with that one.
Okay.
Full disclosure, I would, go to the internet here and see if I can find something that's maybe more consistent. I mean, this is actually looks like it's taken from a McGraw-Hill question, but yeah, that looks to be correct. So the quantitative part is deceptive because they are numbers, but I think the jerseys maybe is the better example where you recognize that they're just identifiers of a player.
Okay, that makes sense.
Okay. Number 10.
Yes.
Here we go. Do you want me to show you how to do the list one stuff here, or do you want like I have a virtual calculator I can pull up if you're not trying to do this on there, if you think you'll be able to use it on the test?
Yeah, I should be able to use it.
Would you like me to show you that now?
Yeah, I'd rather do the fastest way and more
Okay.
efficient way.
Yes, the way to get the right answer is to put this in the list. So give me just 30 seconds here to get this pulled up.
And if you could show me how, that'd be great.
Yes. All right. So it's a TI, it's a virtual TI-83. It's gonna be really similar if you've got a TI-84.
I do have a TI-84 with me.
Okay, so here you go. If you're seeing my screen here, you should be seeing the calculator now. There it is. All right, so you go to, let me get the right place, stat edit. I'll write that down here.
Got it.
And then hit enter. So your cursor should be there in L1 and you enter the data. And data entry is the most important part. I would double check that all your values are correct when you've entered it. It will mess up anything if there's even one number off. 15, 12, 14. So the 10 means it's the 10th value. That's a good check too, to make sure it's the right number of values. Let me know when you get all your data entered and I'll talk about what to do next.
Okay.
And this would apply to that earlier question with the percentile, or with the Q3 and Q1 also.
Okay.
All right, so I like to quit. Some students don't do that, but I think it's good to just kind of exit that place that you're at. And then you go back to stat. And this time you go over to calc. So you just hit the right arrow, and you're gonna hit one variable stats. Now yours is probably gonna pull up a screen that refers to list one. I have to enter list one here. This is obviously an old version. You should just be able to hit enter. Like yours should just pop out and give you numbers like these. So let me know if you see that.
And then you went to, yes, I do see that.
Okay, so if I hit the down arrow, we're seeing stuff that we want. Q1, Q3. Okay, so Q3 is effectively the 75th percentile. It looks like the reason there's a discrepancy is there's kind of another way to do this that is, you know, I mean, this is close enough. I don't know if you want us to give you the exact formula, but this should get you the right answer.
Okay, yeah, I see that.
So that's it. And that would have helped you find the interquartile range in the previous problems, because you get Q3 minus Q1. It doesn't give you that. It doesn't give you but you have to calculate it. Gives you a bunch of stuff here. Let me just see if this will do percentile. It's been a long time since I've looked, because I don't use this ever except when students ask me, because there's way better tools out there. But so yeah, it looks like that's all you've got. Okay, so I'm gonna jump back to the other screen. If we need to, we can always come back to that. So I'm gonna go 75th percentile and move on here.
Okay, that was really helpful. Thank you.
You're welcome.
Definitely going to use this.
I mean, whenever a teacher says not to use something, it's probably because it's the more efficient way.
Yeah.
All right, here we go. From a population of size 500, a random sample of 50 items are selected. Okay, so we assume it's random. That's good. The mode of the sample. The mode is the most frequent observation. Okay, so let me just give you an example besides this right here. So there are probably 500 student athletes at the university or more, probably more. If they chose 50 volleyball players, would they tend to be taller than other athletes?
Yes.
So that doesn't necessarily tell you that it's a great representation of the sample, but the mode might tell you that the mode might be, hey, everyone's this height and they're much taller than everyone else. So you got to be really careful here. If it's random, though, we assume, though, that they really truly grabbed, a section of everyone. So what we can ever say is that it will for sure be equal to the mean of the population. Like the only way to make it equal to the mean of the population is if you sampled everyone. Okay. And it can't be equal to the mode of the population, because you'd have to do everyone. What it really is it can be bigger or smaller or equal to, depending on your sample. chance of the sample. But you could bias it to be above or below. I don't know. I don't know what a short. I guess gymnasts might be shorter. And if you sampled 50 gymnasts, maybe their heights are shorter than everyone else. So it could be lower, could be taller. But the point is that the random sample is a representation of the population. It's just not necessarily going to exactly equal anything in the population.
Okay.
All right, let me give you a quick example of this. So let's just say that there's some event X and the probability of X is, let's just go 0, 1, and 2. And this is 0.5, and this is 0.2, and this is 0.3. So this is what they're referring to. The relative frequencies are the numbers in this column.
Okay.
Okay, and you can see that they add up to 1. Okay.
Oh, okay.
And so, but in terms of like what you might see on a like something you might sample, the frequencies are like the actual frequencies would be like, it might be like 5, 2, and 3, but the relative frequencies are, let me do that over here, is 5 out of 10, 2 out of 10, 3 out of 10. And you can see that those still add up to 1.
Okay.
Number
13.
Yeah. Observational study. So an observational study means that you are going out and you're just watching a group. You're not getting involved. So there's no involvement. You're a spectator. Okay. So you don't have control because you're just watching. You're seeing like how many people go to a certain restaurant in a day.
Okay.
So the answer is it's not controlled. It could be numerical, like you could be measuring how much people spend at Starbucks in the morning, or you could be, it may not be numerical. It might be, jersey numbers like we talked about, but you're not involved.
Okay.
All right, so 14, this one's a more complicated problem. All right, so this one, they give you a lot of stuff here. They say the probability of A is 0.3, probability of B is 0.55, A or B is 0.7. That's kind of interesting. And then they want A given B. So this line here means given. And if that's not clear, I can give you some more explanation on that. I'm looking to see if it does, if you've got this formula here. So they do give you some formulas that are useful on this problem. There's a lot here, so I'll try to make this simple for you. They give you all of these. The one you want, which, and it's just so much here. I'm sure as a student, it's just overwhelming. You want this one.
Okay.
I'm like, well, how would you know? Well, go to what they're asking for, right? Try to go for that. So that and think of A as being the first letter in the formula and B is the second letter, because what they sometimes will do on tests is they will switch the letters. They will want B given A, and you have to know to flip all the letters. Did you see that in class?
Yes.
Okay, but this one's just here. It's like, okay, A given B is the probability of A and B, which you don't have, by the way, but you do have the probability of B, so that's good. Like we have one of the numbers. To find the probability of A and B, we're going to use another formula. We're going to use this formula here. Now you might ask, well, Matthew, why am I using that one, not the one below it? We have more of what's in this top formula. Okay, we know A, we know B, and we know A or B. So we're using that formula here. Let me just kind of make a note from here. So A or B is 0.7, A is 0.3, and 0.55, and then minus, and I'm just going to call this X because I don't want to write the whole thing out and be overwhelming. That's whatever we get for X is going to be in the numerator here.
Okay.
Okay, so we got 0.7 equals 0.85 minus X, and you add X to both sides. You can move the 0.7 over. X equals 0.15. That's the number that goes in the numerator.
Okay.
So it's 0.15 over 0.55. And then we just hope, we pray that it actually is on the list there. I believe it's the first one there. Looks like it's letter A.
Okay, that made sense.
Good. Good. There's a few other ones here we didn't touch that I'm sure they're fair game on the exam, but this is what we've got to deal with. Okay, we'll answer this question in a moment here. It says height is an example of a variable that uses the blank scale, but you need to know them all. Okay, so let's talk about the ones that common ones here. So nominal, we've kind of already talked about. You can think of it as names or categories. And we talked about jerseys. We talked about like zip codes is kind of one that's pretty common. They try to disguise them because you're in college now. Ordinal is, it's got to have a certain order to it. Okay, so you might be leaning towards height on that one, but ordinal is typically used for like scales, meaning like the like how are you feeling today scale, like from 0 to 10. You know, agree, disagree, somewhat agree, kind of that type. Like there's a natural ordering to it. And so then ratio is the most common ones. That's the things that we use all the time, like money, weight, I don't know, distance, things like that. Interval, the one big one that's interval is temperature. And you probably have a slide or two in class from these. But I'm pretty sure height is an example of a ratio data. But I always check these because, yeah, this is ratio. And you might wonder why it's not ordinal. Ordinal are more of just, not sure what the right word is, but ratio is these things we tend to measure.
Okay.
But you know, the fair question would be to ask for any of these on a test or quiz, you know. All right, moving on here to 16. By the way, the lessons are 50 minutes. I'm sure you saw that in the email, but we've got plenty of time here to get through the rest of these and maybe some other stuff.
Okay.
So the numerical value of the standard deviation can never be, these are awful. So when they, so what is standard deviation? It's this measure of spread, okay? And it's got a formula. It's like sigma, you know, x I minus x bar squared, you know, n minus 1 square root. So it's got a formula, but like what can it not be? Well, it can never be negative. All right. Because it's a measure of spread, you can think of it as a length. It's like a length. We never talk about distances being negative, even if one's east and one's west. The reason, I don't know if you want a reason for why like one of these isn't true, but it has to do with variance being between 0 and 1. And when you take a square root of a number between 0 and 1, it gets smaller or larger, or it gets larger, which is weird. But when it's bigger than 1, it gets smaller. That's why these two are paired together. So variance can also never be negative because variance is like you could replace this question with variance, you get the same thing.
Okay.
All right, two events with non-zero probabilities. So think of event one, maybe a coin flip and rolling a dice. Sometimes it's good to give some context to these. And the thing here is that what this question is really asking is like, do you understand these things like independence and mutually exclusive? Mutually exclusive is that like there's no overlap between them. And I used to use some certain examples here, but like the best one I think of right now would be like a light being on or off. There's only like two possibilities. Sorry to be morbid here, but you're either dead or alive. Like mutually exclusive means there's no way to be both. Cannot be both. Is that clear?
Yeah, that makes sense.
Okay. Now independent means that one does not affect the other, which is different, because that means they could both happen. Like your event one could be a heads, your dice roll could be a 2. They don't affect each other. They are independent. And one doesn't affect the other. Like you winning a volleyball game has no bearing on the basketball game, I would think. They're but a lot of times these words get used interchangeably, but that's not true. They're very different in this class, independent and mutually exclusive. So that sort of tells you that they could be both. Because like the coin flip and the dice roll, they're separate events, and they are independent.
Okay, that made sense, and the examples helped.
Okay, great. Now, just check here. I'm always going out to the internet, some of these weird ones. I would double check this one with your notes.
Okay. I'll flag it.
Yes. Like I feel pretty like if I were taking it, because I don't really like this wording, but sorry, I just double check one more thing here. Make sure we get this all done. So the other, yeah, yeah, go ahead and flag it. I am seeing more references to this one, and they're using this idea that if the probability of one event, if you know it, then the other one must be 0. I'm not sure I agree, but these are, if this is for a grade, I'm always sort of going out and suggesting using the ones that are thumbs up on here. Yeah, okay. I guess I would change my answer to this one if I were getting a grade on this.
Okay.
But still, these descriptions still apply of independence and mutually exclusive. None of that really changes based on what we just talked about. All right. This kind of may answer it here. If X and Y are mutually exclusive, actually this you can tell your teacher there's a mistake here. It should be A and B.
Oh yeah.
Probability of A 0.41, probability to B 0.64. So if they're mutually exclusive, that means you can be one or the other. So this idea of the probability of A given B is no good here, because if you're given B, that means that A doesn't exist.
Okay.
I hate to go back to the morbid example, but what's the probability of alive given dead?
Yeah, that makes sense.
It's zero, because it just doesn't happen. It's one or the other. And that's one of these, like, I hate using the word trick question, but that's what it is. Did this just have 18 questions in it?
It goes up to, I think 20.
I thought I saw 20 in the email, but when I looked just now, it didn't, it seemed like it ended right there.
Let me see. Yeah, there's just 2 more. Do you want me to send them?
Let me look at them on my, the Gmail client didn't, let me grab them here another way. Okay, these are, at least these are not too bad. I've got them now. I just need a moment to get them up on here.
Because I thought it said 40, but then I was like, wait, I'm confused. And it only goes to 20.
Thank goodness.
I was like scared for a minute.
Do you know how many questions are on your test tomorrow?
20.
20. And is it like this where it's
Yeah,
multiple
he
choice?
said if you could do the exam simulation, you'll be perfectly fine on the exam tomorrow.
Well, that's comforting.
Yeah, he says his tests are easier than his homework, and they kind of are so far. I've noticed.
Yeah. Okay. So this is number 19. The blank
Yes.
can be interpreted as the standard deviation. Standard deviation a data value is from the mean of all the data. I mean, this is one of those where I just have to give you the answer. It's a z-score. The z-score tells you how far you are from the mean. It's a normalized value. I don't know if there's anything more to say on that. And then last one here. Which of the following is a measure of variability? There's more than this, but I'll circle this and add the other ones. Standard deviation and variance are common ones. These other ones are not measures of variability.
Okay.
Couple minutes left. I don't know if you have a short question we can answer, or if you have anything else you're unsure about, we can talk over.
No, you pretty much like went through everything, and you gave really good examples that I'm gonna go back over that like helped me.
Great. That's great to hear. Let me